Welcome to our Zero Trust Security practice with Consul-Terraform-Sync and Palo Alto Networks Next Generation Firewall. My name is Sebastian Maniak. I'm a Senior Solutions Engineer at HashiCorp. And today we have the Global Solutions Architect of Cloud Security Automation at Palo Alto Networks. Our agenda for today is to give you an introduction of Zero Trust Security with HashiCorp, talk about securing the data center, why next generation firewalls are needed in the cloud, and how we can integrate next generation firewalls using Consul-Terraform-Sync. So here's a little bit about HashiCorp. We build tools for practitioners, and these are used extensively. There's a good chance that engineers at your organizations use them today, and many of these projects have been downloaded millions of times. They are a foundation tools for the most important workflows for companies large and small. HashiCorp creates workflow management tools to accelerate modern application delivery. We are living in a multi-cloud security world. Right? Zero Trust relies on who you are and what you are using to determine access. To achieve this, you need to have identity-driven controls. HashiCorp's Vault product pulls double duty as an identity mapping tool, as well as it provides encryption as a service. We also have Consul. Consul identifies and secures network layer connectivity for applications. And lastly, we have Boundary, which secures end-to-end users with SSO to our connectivity of applications endpoints. Securing a data center was easy. All unauthorized access or access could be restricted in a traditional data center. Networks were trusted, apps and databases can interconnect easily because they're on the same network, the same VLANs. The four walls and trusted networks protected secrets and sensitive information. But what happens when we move to the cloud and have a more modular applications and services with dynamic IPs? The migration to cloud means teams and organizations must rethink how to secure their applications and infrastructure. Transitioning from traditional on-prem data centers and environments to dynamic cloud infrastructures is complex and introduces new challenges for the security organization. There are more systems to manage, more endpoints to monitor, more networks to connect, and more people that need access. This is especially true as organizations adopt a multi-cloud, hybrid cloud environment. Increasingly, these challenges exponentially. Securing traditional data centers requires managing and securing an IP-based perimeter with networks, firewalls, hardware security modules, security information event management tools, and other physical access restrictions. But those same solutions really are no longer sufficient as organizations move to the cloud. Securing infrastructure in the cloud requires a different approach. And the challenges of networking in the cloud are often some of the most difficult aspects of adopting a zero trust security model for enterprises. The combination of dynamic IP addresses, a significant growth in traffic originating within the network, also known as east and west traffic, as microservice patterns are adopted and the lack of a clear network perimeter poses a formidable challenge, right? Additionally, the dynamic nature of the cloud workloads adds to a complexity of securing the workloads. Networking services should be provided centrally, where IT and the cloud teams provide a service registry and service discovery capabilities. Having a common registry provides a map of what services are running, where they are, and their current health status. The registry can be queried programmatically to enable service discovery or driven network automation of API gateways, load balancers, and other critical middleware components itself. HashiCorp Consul provides this multi-cloud service networking layer to discover and secure connect services. Consul can also dynamically program the Palo Alto devices with secure policies in order to protect the workloads in the applications. When we talk about console, we focus on 3 different use cases. We have our service registry and health monitoring to provide a real-time directory of all the services with their health status. We have our zero trust network with service mesh to secure service-to-service communication with identity-based security policies and encrypted traffic with neutral TLS. And of course, we have our network infrastructure automation with service discovery for dynamically reconfiguring as services scale up or down and automatically provisioning network-related tasks. Console has 2 elements, right? And also provides this foundation of cloud networking automation using that shared services, right? Console's 2 elements are a highly available all-active cluster of console servers. This is where service catalog resides, the state of the application and services. Then we have the applications and the services themselves, which run a console agent. That agent is constantly monitoring the local health and availability of that service, and it's propagating that information into a cluster. So we now have an always up to the millisecond visibility of all our apps and services, where they are and how to get to them, and to ensure when things that request access to a service, we are going to give back a reliable, accurate destination for them to get to. With our partnership with Palo Alto, we have built many ways to deploy zero trust security models with our tool sets. We have, of course, Vault integrates with Prisma Cloud to secure and distribute secrets to containers. We have Terraform, verified providers for PanOS. We have Terraform verified providers for Prisma Cloud and Terraform Cloud integration with Bridgecrew. And of course, we have Console, where Palo Alto Network's Terraform modules for Consul-Terraform-Sync enable this network infrastructure automation for security operators to dynamically configure policies, address groups, and deploy a PanOS config. With that in mind, let's swing over to Magar to introduce you to the Palo Alto security, zero trust security.
Thank you, Seb. So before we dive into details on why we need next generation firewalls to protect your cloud environments, I want to set the stage around when we're trying to think about implementing zero trust for enterprises, how we approach this problem. So there are 3 main areas that we focus on when we're talking to customers, right? So there are users, we need to secure applications and infrastructure. One of the interesting things you can see here when we put all this into a metrics, all these 3 areas have common 4 verticals that we need to address. Identity, securing the device itself or the workload, and securing the access to those workloads, and also securing the transaction. So when we truly talk about implementing zero trust enterprise, we are talking about eliminating that implicit trust Seb was talking about earlier, using the HashiCorp products. The other side of the story is how can we continuously validate the transactions? How can we continuously validate every digital interaction that we see? So in this webinar today, we're going to focus on those 4 areas that are highlighted in red. How are we going to secure user access and their transactions? And how can we secure application access, application to application communication? And how can we protect the transactions between those applications? Now, if we look into this matrix, how our products fits into this metric, this is where our next generation firewalls fits into the picture, right? Next generation firewalls helps you secure user access, user transactions, and application access and application transaction. While next generation firewalls provide this, HashiCorp Vault boundary, and console allows us to provide security on identity of applications, identity of users, and application identity of applications as well. Now, before I further dive into details, we need to understand the attack surface. So we spoke about the applications are no longer hosted within four walls. With the re-architecture of data centers, customers move their workloads to cloud. Now, suddenly your attack surface is broadened. So you have your workloads running on different cloud environments, you have internet-facing assets. This is a perfect opportunity for attackers. And also the threat landscape is increasing, and we see different attacks we never seen before. From easy to execute to very advanced attacks based on the targets. So why next generation firewalls are really needed to protect your cloud workloads? So if you look at the history, the recent past, what we've seen, Log4j is top of mind, impacted 3 billion plus Apache servers. Most enterprises are still dealing with these affected services. We are not even done dealing with this, and we're already seeing something called a Spring 4 shell, was announced just a few weeks ago. And ransomware attacks. Revel, which stands for ransomware evil, is a ransomware as a service operation. It has collected over $123 million in ransomware already. And DDoS attacks. Bashlight is a DDoS attack that affected 1 million plus Linux devices. So one interesting thing here, network is the common denominator for all these attacks. And this is why network security is critical in cloud. So how do we protect these workloads using next generation firewalls? To understand that, we need to look at a typical attack lifecycle. So let's imagine you have a public facing or internet facing workload on the left-hand side here in the green circle. This application can be accessed over the internet. So usually an attacker try to exploit a known vulnerability. That's the first stage of the attack. Once you have access, usually attacker try to download some malware and install that on the workload. Once he's successful with that, the third stage of that is he's trying to establish a command and control channel back to attackers' servers. Once that's successful, this is when it starts to attacker to laterally propagate and go after your crown jewels, which is your most valuable assets within the organization. So if they're successful with that, the next step is usually exfiltrating that data. If not, if it's a ransomware attack, most likely they will try to encrypt your assets as well. So now with that in mind, let's try to map this into different use cases. So the first stage of the attack was the inbound access. So how can you protect inbound access using a next generation firewall? So if you have App ID and threat prevention enabled on your firewalls, first thing what's going to happen is you can define which applications, in fact, you have hosted on your workloads. So for an instance, if you have some web applications running, you can define, I only need to allow web browsing App ID. So this way, the attacker can't really misuse your application and try to exploit unknown vulnerabilities. And threat prevention comes on top of that to make sure that the attacker cannot exploit your servers. And then the second stage of the attack, we see establishing a command and control channel back to the attacker's service. So this is where we can protect your outbound access. Again, you can use application IDs, so you can define a set of applications that in fact should be used when you're establishing outbound connections. On top of that, you can leverage advanced URL filtering. So instead of allowing a set of URLs that you can have, you can add categories, and you can block known and new known and unknown malicious domains using advanced URL service. And also you can use threat prevention and DNS security services on these firewalls to make sure that the attacker is not going to be successful establishing that command and control channel back to their service. And the third and most important part is the protecting lateral movement. This is where attacker would go after your crown jewels, the most important assets in your organization, most commonly known as east-west traffic. By inserting next-gen firewall into the mix, now you can, again, apply app ID and threat prevention to make sure the server's in fact talking to the service that it need and talking the only allowed to talk the right between right applications, and making sure that the attacker cannot exploit your service there. So if you look at a context-based policies that you can configure within Palo Alto Networks firewalls, you can see you can define users to make sure that the users are the users defining these rules are in fact can access these applications. And then of course you can add devices, so you can verify the identity of the devices the users are accessing from. And you can define a set of applications and the service as well. So you no longer specify the ports for these services, you just specify just the application and the 4 ports that would come along with those applications. And then of course you can apply all the security subscriptions, the wildfire to identify zero-day vulnerabilities, threat prevention, URL filtering, and DNS security on top of that. So hopefully you've seen the importance here, why next generation firewalls should be protecting your cloud workloads. Now we spoke about this and Seb talked about Consul, how that solves the problem. Now the next challenge is how we can integrate these two things together. There's no point having these two disjointed solutions if we can't seamlessly integrate these two technologies. So Seb, why don't you talk us through how we build solutions to integrate Palo Alto next-gen firewalls and Consul?
Awesome. Yeah, thank you very much. So what we've developed with all these use cases and in mind for zero trust, really let's dive into network infrastructure automation with Consul-Terraform-Sync. So Consul-Terraform-Sync is a small, robust, lightweight service that really automates those manual tasks of updating policies, user groups on the Palo Alto device automatically based on what was registered in a console itself. So if we do a quick conceptual walkthrough on how Consul-Terraform works, it's the platform team or an application team needs to deploy a new service, a new web app, a new database service, and they want to ensure that that new service will automatically be added to a Palo Alto, maybe a dynamic address group based on tags, or maybe there's a specific user we want to add, but we want to automatically add that new service that spins up to our device group automatically, right? So that service automatically gets registered itself with Consul. Maybe it's just that database, like I mentioned. Consul-Terraform-Sync connects and talks to Consul all the time, right? Picks up that new service instance and follows the tasks that we define to update the address group itself on the PAN-OS device. So it's using Terraform modules that many practitioners have been using already in conjunction with our Consul-Terraform-Sync, really kind of is going to enable your team and our teams to reduce that manual ticketing process. Yes, we do create a ticket to deploy an application or deploy that service, but we can remove that manual task of updating a policy or an address group on a PAN device to be automatically done for us, right? So if that application scales up or down, we can automatically, allow those IPs that were dynamically generated maybe to be added into those policies itself. Once Consul-Terraform-Sync generates that Terraform manifest, so it grabs all the information from Consul, from the service that it was registered, inside that metadata of that service, the application team, says, hey, we need to be in this access group, we need access to this database, to this app, through this network. We identify that in this manifest. And then Terraform itself runs and then implies the changes on the Palo Alto device, right? With the information that was provided from Consul automatically. Right? With this Consul-Terraform-Sync PAN-OS modules, kind of enable that entire network infrastructure automation for security and network operators to dynamically configure these policies, groups, tags on our PAN-OS devices as new services are registered and deregistered. So if a service is going away, we deregister it from Consul, and then it removes the configuration from our PAN-OS devices, which keeps the config very clean and easy to audit and manage later on in the future, especially if you're migrating to some new device itself. You don't have to keep all the old unused configurations on there. Using CTS really, alleviates that ticketing system also, that wait time. It's going to reduce some of the costs from an operations perspective of someone manually going in and updating policies. It's going to improve delivery because we won't have to worry. We don't have to think about, oh, is this new service added to this and then address group itself? And it's going to provide better security because everything inside of what Consul has as our source of truth is going to be able to provide that security and that identity we need. And really our goal with Consul-Terraform-Sync is to accelerate your application delivery by automating network-related tasks, right? And we want to enable that end-to-end automation. That is the key concept of this, is to enable that end-to-end automation to provide that improved delivery and security itself. With that in mind, we have updated many of our Terraform modules. They're available here. There is a QR code we can scan, and it'll get you right to our repos to be able to deploy this and test this out in your own environment. And with that, I'd like to thank everyone so much, and we will move on to the Q&A section.
So we got a few questions here. One question is about panels commits. Can you do commits with Consul-Terraform-Sync? Yes, you can. So the Consul-Terraform-Sync itself support commits. So you have to provide the commit parameter when you're configuring your Consul-Terraform-Sync driver. So you can instruct Consul-Terraform-Sync to perform a commit at the end of every task.
We have another question here just to jump in from Sean. Is the integration tightly coupled with Terraform Cloud, or can it use the CLI or the enterprise? Yeah, so the integration with CTS can be coupled into Terraform Cloud or Terraform CLI open source. So.
There's another question about, can you make the live demo of the tool GitHub style? Not exactly sure what the question here, but I
Yeah, we
presume
could. Sorry, Megara, you can go ahead. But
no, I was just about to say we can make some interesting demo for you guys to try out and host it somewhere out there. So you can add and delete address objects through Git and then kind of see how that add and delete address objects to the groups.
yeah, we also have a console NIA Palo Alto workshop that's free. We just ran one last week, but we can send the dates to everybody when the next one's going to be, where it gives you a full access to Azure environment where we deploy Palo Alto and we demo out Consul-Terraform-Sync in a production-like environment.
And there's a question about, can you integrate Consul-Terraform-Sync with Panorama? Yeah, you can do that today. So it's all about having a Terraform provider. So the Panos provider today that supports both next generation firewalls and Panorama both. So you can in fact point your driver or configure your provider, point that towards Panorama, and that will work exactly the same way a next gen firewall would work. So you can in fact orchestrate creation of device group, template stacks, all that kind of nice stuff that you do on Panorama.
I see another question. The last question here. Can Consul send additional metadata along with address information to the new services? Yeah, we can. We can send any type of metadata when we register that service in Consul, and then we can use that data to build out more advanced Terraform configs and Terraform modules that can do certain things. Provision Palo Alto, update address groups, or update different types of policies on here.